Astronomers and researchers have discovered a new fossil galaxy buried deep within our Milky Way galaxy. Based on information coming in from scientists who have been working with the data from the Apache Point Observatory Galactic Evolution Experiment, they have discovered a fossil galaxy hidden deep within the depths of our own Milky Way galaxy. This information was recently published, and it has shaken and changed the understanding about how the Milky Way grew into the galaxy that we currently have today. The proposed fossil galaxy may have collided with the Milky Way galaxy 10 billion years ago, when our galaxy was still in its baby stages. Astronomers have named this fossil galaxy Heracles, after the ancient Greek hero who received the gift of immortality when the Milky Way was created. The remnants of a fossil galaxy Heracles accounts for approximately 1/3 of our Milky Way's spherical halo. But if the stars and gas from Heracles make up such a large percentage of the galactic halo, why didn't we see it before? This answer that scientists are trying to find lies in the location of Heracles deep within the Milky Way. According to the researchers, to find a fossil galaxy like this one, they had to look at the detailed chemical makeup and motions of tens of thousands of stars. This is especially hard to do in regards to stars that are located in the center of the Milky Way galaxy, because they are hidden from view by clouds of interstellar dust. Apogee allows us to pierce through that dust and see deeper into the heart of the Milky Way when we have to do these experiments and observe the stars across the Milky Way galaxy. Apogee allows us to see deeper into the Milky Way than we have ever seen before. Apogee carries out this experiment by taking spectra of stars in near-infrared light instead of visible light, which gets obscured by dust. Over its 10-year observational life, Apogee has measured spectra for more than 500,000 stars all across the Milky Way galaxy, and this includes the previously dust-obscured core of the Milky Way. If you were to be examining such a large number of stars, it is necessary to find unusual stars in the densely populated heart of the Milky Way, which is like finding needles in a haystack. To separate stars belonging to Heracles from those of the original Milky Way, the team made use of both chemical compositions and velocities of stars measured by the Apogee instrument. Of the tens of thousands of stars that were observed, a few hundred had strikingly different chemical compositions and velocities. These stars are so different that they could only have come from another galaxy. By studying these stars in detail, they were able to trace out the precise location and history of this fossil galaxy. It should be noted that because galaxies are built through mergers of smaller galaxies across time, the remnants of older galaxies are often spotted in the outer halo of the Milky Way, a huge but very sparse cloud of stars enveloping the main galaxy. Since our galaxy was created and built up from the inside out, finding the earliest mergers requires looking at the most central parts of the Milky Way's halo, which are buried deep within the disk and bulge. Stars that originally belonged to Heracles account for approximately 1/3 of the mass of the entire Milky Way halo today. This means that this newly discovered ancient collision must have been a major event in the history of our Milky Way galaxy. This also suggests that our galaxy may be quite unusual, since most similar massive spiral galaxies had much calmer earlier years. As our cosmic home, the Milky Way is already special to us on Earth, but this ancient galaxy buried within it makes it even more special and unique. Apogee is one of the flagship surveys of the fourth phase of SDSS, and this result is an example of the amazing science that everyone can do. Now that we have almost completed our 10-year mission with Apogee. And this new age of discovery will not end with the completion of Apogee observations. The fifth phase of the SDSS has already started taking in data, and its Milky Way mapper will build on the success of Apogee to measure spectra of stars for 10 times as many stars in all parts of the Milky Way, using near-infrared light, visible light, and sometimes a combination of both near-infrared light and visible light. The solar system contains our planet Earth, and the solar system is located approximately 25,000 light years to the galactic center and 25,000 light years away from the rim of the galaxy. If you were to think of the Milky Way as a large record, we would be the spot that's roughly halfway between the center and the edge of the Milky Way galaxy. Based on estimates coming from astronomers, there are approximately 100,000 million stars in the Milky Way galaxy alone. Outside of the Milky Way, there are millions upon millions of other galaxies that contain millions and millions of stars. Apogee is the Apache Point Observatory Galactic Evolution Experiment. This experiment collects near-infrared spectra in order to carry out a systematic survey of all components of the Milky Way, using simple selection criteria. The survey is a large-scale stellar spectroscopic survey conducted in the near-infrared portion of the electromagnetic spectrum, the H-band, which provides details of wavelength coverage. In comparison to the optical wavelength surveys, Apogee can more easily detect light from stars that are located in the dusty regions of the Milky Way, such as in the disk and the bulge of the galaxy. The high-resolution effects of Apogee spectra provide detailed chemical and kinematic information for stars that are targeted within the Milky Way. Like, comment, share, and subscribe. Let me know what you think about the use of this Apogee spectrograph to analyze, assess, and observe stars deep within our Milky Way galaxy. And are you just as fascinated as I am about this fossil galaxy called Heracles that has been found deep within the core of our Milky Way? Thanks for watching.